we know that our x hat null k is the original time response, and our x hat 1k is the our accumulated response sequence with respect to k. So then to obtain the x1k, the equation by solving that differential equation, we can get the equation to solve for x1k. But remember, x1k is our adjusted data, the one that was created by the accumulation. So we need to go to get our original data. So to do that, we just subtract x1k, s1k plus 1 minus x1k, and then from there we can derive the equation for our for our prediction. The x null k plus 1 equation can be derived from there, and that equation can be used to predict n step k plus 1, k plus 2, and so forth. In our case, we use an approach. We use this equation, but we use an approach called the rolling horizon approach. And this consists that, for example, we have today's Friday, and I'm trying to predict data for Saturday. So I will take four data, the window size, 4 previous data. So I will take Monday, Tuesday, Wednesday, and Thursday. These are my 4 data plus my today data to predict Saturday data. And then if I have my Saturday data, so I'm on Saturday now. So I want to predict Sunday. I will use instead of using Monday, because I move one step forward, I will use Tuesday until Saturday to predict my Sunday data. So that's called the rolling horizon method. So then I have the formulas of our GM cosine. This is actually the model we are interested in. We want to see how it's performed. But that model is based on the GM1. It's the same model, except that we have another cosine function that is added to the GM. And this model is this model is applied to this study is taken from the research conducted by Dr. Wayne, Dr. Comer, and Dr. Begasho, I think this year, around May or June. So the formulas of the GM cosine is similar. As you can see now, we have a function added on the right inside section, the right inside with the cosine function. So now instead of having 2 parameters, we have 3 parameters, A1, B2, B1, and B2. And also for our coefficient matrix, we have another column that is added with the cosine function. And all those parameters will be estimated simultaneously, except the omega. Since our omega is inside the cosine function, is not estimated with the other parameter. Well, we did it by trying the error. As we know, the angle is supposed to be between 0 and 1. So we try after trying which angle, we will just determine which one help us to have a better prediction. And as you can see here, the same optimization process. We get our equation for x1, and here where k here is just a k here is just I call it a constant. K is just a constant, and then from there, following the same process as the GM11, we can derive our prediction equation, and also we use the rolling horizon approach. As I said earlier, we use 2 S-shape model. I will go really quick on the S-shape. As I said, they are mostly used in the for predicting pavement performance model, and some of the S-shape, the sigmoidal model form include the logistic curve, variables, peer equation, peer curves, Richard curve, which is a generalized logistic curve, and also the Gompers, Weibull, and you can find more from the paper of Rowe et al. 2009. So this is our other 2 S-shape model we will compare with our GM cost. The first model here is the model used by North Carolina DOT, and the second model here on equation 14 is the one used by Arizona DOT, but also South Carolina DOT use the same model, where A, B, and A, B1, C, and O are parameters to be estimated.